Hi there. In this video we're looking at surface area and specifically how to find the surface area of a frustum. If you've not watched the video on volumes of frustums, I go into a little bit more depth about the strategies for working out the size of the cone we've cut off the top of the big cone to be left with our frustum. So it's probably worth having a look at that video before this one. But let's just jump right into it. So let's recall that a frustum is a cone that's had its chopped off. So we can just draw on the top that's been cut off. Okay, so now let's have a look at how we can work out the surface area. So our strategy from before still stands. We're going to label up all the faces. Well, we've got this one face on the top, we've got this face on the bottom, and we've got this curved face on the side. We'll call that one 3. So 1 and 2 are relatively easy to work out the area of. In fact, let's just do that. Let's just get that done, pick up those marks in the exam. Let's dive headlong into there, and then we can have a bit of a think about how we deal with 3 in a second. So the area of 1 is pi r squared. The radius of 1 is 2. So we get 2 squared is 4, so we get 4 pi. Similarly, the area of number 2 is pi r squared. The radius here is 4, which squared is 16, so that gives me 16 pi. Okay, so let's have a quick think then about how we can work out the surface area of 3. So if we've got a frustum, and the surface area of the frustum, it's the same strategy we used in the volumes video. We work out the curved area of the whole cone, and then we take away the curved area of the small cone. So it's the big area minus the small area. Now let's change that to a 4 there. Okay, so I have just changed the question slightly so that the slant length is 4 rather than the height. We could work it out if the height was 4, and we just need to use some Pythagoras theorem to work out the slant lengths. But just for this first example, I want to be able to focus on the strategy of doing the big area, take away the small area. So I don't want to confuse the issue with Pythagoras' theorem. I don't think there's any reason we couldn't do it with the height. I just really want to specifically focus on this. Strategies are the same. So if this slant length was 4, to work out this big surface area, or the big curved area, we need the whole slant length. And to work out the small curved area, we need the little slant length. So either way, we need this length here. I'm going to call that L small. Okay, now we've got a handy hint as to how we can do this. So the base of this cone is 2, and the base of this cone is 4. And so that tells me that this cone is half as big as this cone. It's half the size. So if this is half of the whole thing, well, if that's half of it, then it must be the same as the other half, which is 4. So I know that that slant length is 4. If you want to see a little bit more detail on the strategies we can use, if it's not half, if this was 4 and 3 or 4 and 1, and then hop on over to the volume video for Frustums and we'll sort of talk through it in a bit more detail there. But just for this one, I'm going to assume you've watched that, so I should be fairly confident with that. Okay, so the small slant is 4, which means that the big slant, the length big, is equal to 8, which is just 4 plus 4. So now we can work out each of these areas. So the area big, again, is pi RL. The big radius is 4, and the big slant length is 8. 8 4s are 32, so we get 32 pi. And the small area, well, pi RL the small radius is 2, and the small length is 4. That gives me 8 pi. So the area, or the curved area of the frustum, is 32 pi minus 8 pi, which is equal to 24 pi centimetres squared. So we've got the 3 lengths that we're after. So now to find the total surface area, we add those 3 numbers together. So 4 pi plus 16 pi is 20 pi, plus the 24 pi is 44 pi centimetres squared, which again we could type into a calculator and get to a degree of accuracy. Cool.